The jugular venous pulse and its waveform gives an idea about what's happening in the right atrium of the heart. And as a whole, it gives the idea of what's going on in the entire right heart during a cardiac cycle. So this waveform is plotted in a graph where y-axis represents pressure and x-axis represents time. That means in actuality it is a pressure waveform. So initially what happens? There is increase in the jugular venous pressure due to something known as the atrial contraction. And this A over here represents atrial contraction. The A over here should remind you of atrial contraction. Then once the atria has reached a peak pressure, that is the right atria over here, then atrial relaxation occurs. Over here we get to see there's a dip in the pressure, and this dip leads to a depression, and this X over here represents atrial relaxation. The X in relaxation should remind you of that. After that, once atrial contraction and relaxation has taken place, what happens in the cardiac cycle? The ventricles go into contraction. That means it's time for the right ventricle to contract. Once the right ventricle starts contracting, after a certain point, there will be pressure building up over the tricuspid valve over here. Now, as more and more pressure builds up over the tricuspid valve due to increasing pressure in the right ventricle, the tricuspid valve will bulge into the right atrium. And this bulging of tricuspid valve into the right atrium will decrease the space in the right atrium and will increase the pressure. And that is why there's an increase in the pressure of the right atrium, which is demarcated by C over here, tricuspid bulging. So it is tricuspid bulge. The C in tricuspid should remind you of that. Now, as the ventricular contraction proceeds further, what happens? There is opening of the semilunar valves, and as the semilunar valves open, the pressure within the right ventricle starts to decrease, and the bulging of the tricuspid valve gets reversed. And as the tricuspid valve bulging gets reversed, the pressure within the right atrium again falls, right? And this step is demarcated by a X prime, and this represents there is downward movement of tricuspid valve or reversion of tricuspid valve during ventricular contraction. Now, as this is a second dip in the curve, which is similar to the X mentioned previously, it is mentioned as X prime. As the ventricle starts to empty out, the ventricular volume decreases. As the ventricular volume decreases in the fixed pericardium, there is space for atria to expand, and at that point, atria starts venous filling in the atria. Now this V over here represents venous filling of the atrium. Venous filling of right atrium. And as venous blood fills in the atrium, the pressure within the atria again starts to build up and goes up. By now, the ventricular systole or ventricular contraction ends, ventricular diastole begins, and the atria starts emptying its blood through an open tricuspid valve. Emptying into RV through open tricuspid valve. And as the blood gets emptied into the right ventricle, the blood content within the right atrium decreases and the pressure also decreases. So these are the key components of a normal jugular venous pulse wave.